Welcome to the tables, domain, and range of quadratic functions lesson. My name is Mr. Rollo, and I'll be your instructor for this lesson. Now, let's go learn the math. The objectives for this lesson are to understand and identify the domain and range of a quadratic function. Remember, the domain is all the x values that you can plug into an equation, and the range is all the y values you get from those x values. Fill in a table of values for a given quadratic function, and graph a quadratic function by plotting points. Here is some important vocabulary you will need for this lesson. First, a quadratic function is a function that can be written in the form y equals ax squared plus bx plus c, where a is not 0, meaning it has to have an x squared term. A parabola is the graph of a quadratic function. Here are the steps to graph a quadratic function. First, substitute selected domain values in the place of the variable. That means pick numbers for x and plug them in. Complete all indicated operations to identify the corresponding range value, and write your answer in a table or as ordered pairs. Graph the ordered pairs, and then connect the dots. Now, let's go work the math. In example 1, we will graph the function f of x equals x squared minus 3. So the first thing I'm going to do is pick a few values from the domain. So I'm going to pick -3, -2, -1, 0, 1, 2, and 3, because that'll give me a good idea of what this graph should look like. So remember that when you plug in a value to a function, you're really plugging it in with this set of parentheses here. So you really get parenthesis -3 squared minus 3. It's easy to make a mistake here because -3 times -3 is +9, whereas -3 times 3 is -9. So I get 6. If I plug in -2, I get 1. If I plug in -1, I get -2. If I plug in 0, I get -3. And if I plug in 1, I get -2. If I plug in 2, I get 1. And if I plug in 3, I get 6. It's important to notice that the values are the same for the negative and positive integers. So graph your points. So here is -3, 6, and here is +3, 6. Here is -2, 1. Here is +2, 1. Here is -1, -2. Here is +1, -2. And 0, -3. And of course we need to connect the dots. And this makes a smooth function, meaning that it hits every value in between the dots. Well, now what's the domain? The domain is all real numbers, because you can plug in any number for x squared and get a y value. However, what's the range? You will notice that the range is only the y values greater than -3. If you look at the graph below y equals -3, you will notice that there are no y values that the graph touches. So we include -3, and these y values go on forever. So it goes from -3 to infinity. In example 2, we are asked to graph the function f of x equals -x squared minus 6x plus 5. So we should pick some x's and plug them in and see what we get. Well, what x's should we pick? Well, in general, you should pick x's that are easy to plug in and see if you notice a pattern. So I'm going to start by plugging in -1, 0, and +1, because those are numbers that are particularly easy to plug in. When I plug in -1, I get a y value of 10. When I plug in 0, I get a y value of 5. And when I plug in 1, I get a y value of -2. So you'll notice that the y values are getting smaller as we move right. So let's try and pick some values that go to the left. Let's get some bigger y values. So if I pick -2, for example, and plug it in, I get 13. And if I pick -3, I get 14. And notice how the difference between the y values is getting smaller. So as I move left, I'm coming closer to the vertex, or the highest point of the parabola. So if I pick -4 and plug it in, it turns out I get 13. And let's pick one more. Let's pick -5. If I plug in -5, I get 10. So now I have a lot of points and a lot of information, but notice that some of these y values are pretty big. And because the y values are pretty big, I'm going to have my y's count by 2. It's just a little trick that makes your life a little bit easier. So start plotting your points. -1, 10. 0, 5, 1, -2, -2, 13, -3, 14, -4, 13, -5, 10. And take a look what's happening here. You'll notice that the top of this parabola is right here. That's because there's a negative coefficient in front of the x squared. It makes the y's flip upside down. We fill in a smooth parabola, and there's our graph. Notice again the domain is all real numbers. I can plug in any number to this function. But the range, however, is numbers that are smaller than or equal to y equals 14. So we can write it like this, or we can write it like this. Don't forget to include the 14. In conclusion, a quadratic function is a polynomial whose highest power is 2. These functions are often used to model vertical motion because, for reasons you'll learn in physics and calculus, gravity has square units. To graph the function, pick some x values from the domain and plug them in to get ordered pairs, graph the ordered pairs, and connect the dots. This is good advice for any function you're trying to graph. This is Mr. Rallo signing off. Now go do the math.